Okay, so welcome back to COP1334. I'm Professor Lusby, and this is part 2 of the election results tutorial video. And in this part, I really want to go into the details of how we take the pseudocode and translate it directly to C++, right? The actual implementation of pseudocode to C++. And just to kind of refresh our memory, if you look at our pseudocode design, when we created this main file, we basically came up with 4 or 5 main things that we needed to do. The first was to create this input candidate info that's going to grab all of the information from the user and stick it into the arrays. Next, we created something called calculate candidate info, and the whole point of that was to calculate those percentages that we need to show. And how do we know this? Because basically our requirements told us that, right? Is that we need to show these percentages here. Next, we call determine winner module, okay, and that's actually going to go through all the array information and figure out who won the actual election. And then finally, once we have all that information, now we can go and display all of this candidate information and make this, nice, pretty table like they want us to do. So essentially, we've got 4 main modules here that should create our program. So once we have those 4 main modules in pseudocode, basically what I do is I leave main for later. Okay, main's kind of always the last thing I work on. And if you watched part 1, you remembered where I took the pseudocode from main and I copied and pasted it below, and I created these what I call placeholders for each one of those modules. Now, the first thing we need to do is, if you remember in the pseudocode, all of these modules from part 1 are all void functions. So the first thing we need to really look at is these, we need to pass information to these functions. We listed that as input and output in the pseudocode, but we need to translate this to actual data types that we're passing to those functions, or an actual return type. And so we need to know how to examine each one of these inputs and each one of these outputs and determine how that translates to parameters. So for instance, for the input, the last name array, okay, that's how we get this string AR last name parameter that you can see is an array. So that's how we get our first parameter, is through this first input that we need. The next parameter, the AR vote count array, is this second input here that's needed. And then finally, this third parameter, max size of the arrays, okay, is this third parameter right here that we pass to the function. So all of those inputs translate to parameters. Now the question is, well, what about these outputs? And you can see that what we're doing is we're taking this input array and we're inputting, we're taking all the candidates' information from the user, and we're going to place that information into the last name array. So we don't need another parameter. We already have the last name array, and because last name array is an actual array, anytime you change an array, you're essentially passing by reference. So there's no need. Remember, anytime we want a parameter for output, I told you that we need to stick in this AND symbol in front of the parameter. Well, if it's an array, you don't need to do that. That's just automatically done kind of behind the scenes. Okay, that's basically what this means to the compiler, is that here's an array, I'm passing it by reference. So we don't need to change, we don't need to include another parameter, we don't need to change the parameter. Automatically, this AR last name array can be used for output. For the vote count array, same thing. We're already passing the AR vote count array as input, and we're just going to basically place the data inside of it. So inherently, we can use this one as output because it's also being passed by reference. It's an array, so we don't need to add another parameter for the output here. And then finally, this third output, number of elements stored in the array. Notice that this is different from this. Max size of the array is how many elements can the array hold if it's full, right? Here, this output number is the number of elements, the number of candidates that we had. How many elements do we actually have in the array once this module is done, right? We may not have 5 candidates. Maybe we have 4. Maybe we have 3. Maybe we have 2. Okay, so this output here is to tell the function that's calling it how many of those candidates did we actually store in the array. It may not have been all the maximum number of candidates. So we need an output to represent that. Notice that this is really the only output that we need. So that being the case, that's why I created a return type as an integer here to basically pass back this value here, this number of candidates value here. Okay, so that's why you see the return type as int, is this int represents this third output that is not represented with the parameters. Okay, so I just wanted to be really clear how each one of these inputs and each one of these outputs translates directly to parameters and the return type. Okay, so that's always the first step. Whenever you're implementing pseudocode and you're implementing pseudocode for the module, you need to look at all of the input, all of the output, and figure out how does that map to the particular parameters, to the particular return type. Once you have that, now we can actually start to implement the code, the process, right? The process inside the module, right? That's the whole point of defining this module is that it's going to perform some process for us, and we see that the process for input candidate info is we want to input the candidate's info from the user. So let's go ahead and go inside of our input candidate info modular function here, and this is the same pseudocode that we came up with in part 1. The only difference is that I've actually put the C++ implementation behind it. So for instance, that we have some pseudocode here describing that we want to create a loop and go from 0 to the max number of candidates, right? That doesn't necessarily mean we're going to use every element in this array, but it means that we could, if we wanted to, right? If we have that many candidates, we can always fill up the maximum number of candidates in the array. So we're going to create this loop. In order to do that, that's why you see this for statement here. We start at 0, we go to the max number of candidates, okay, and we increment by 1. So that's how we can implement the pseudocode of looping directly to C++. Now inside the loop, what you're going to see is the pseudocode is asking us to prompt an input. So we're going to do a bunch of cout and cin statements. We just need to make sure that each one of our cin statements is placing the data into the appropriate array. So if we're inputting the last name, we want to put it into the last name array, and we want to use the appropriate index. Whoops, excuse me. We want to use the appropriate index. So that's the whole point of this I loop here, is so that every time we loop, we can increment I. We'll start at 0, we'll go to 1, we'll go to 2, and so each one of our inputs is stored sequentially inside of this array at wherever I is. Okay, so same thing here. Prompt the user for the candidate's vote, and then we input the candidate's vote into our vote count. Okay, so same thing. We cout, we do a cin, and then to be on the safe side, I created this variable called number of candidates to basically keep track of how many candidates we have entered, because what you're going to see is this is that additional kind of, if you remember from part 1, I said that I kind of added some additional logic here. And I basically gave this program the ability to say, hey, do you have another candidate? Because maybe we don't have 5 candidates. Maybe we have 4. Maybe we have 3. And if the answer is no, you know, I put in this nice little break statement to break out of this for loop and just basically terminate the process early so that we don't have the maximum number of candidates in our array. Okay, so that's kind of the whole point of this code right here, is to just say, you know, hey, would you like to jump out of the loop early before you have the maximum number of array entries? And then finally, you know, we basically keep looping, right? We keep looping, get all of the the last name and the vote count information. Once we're finally done, right, we need to make sure that we return the number of candidates entered into the array. That's what this number of candidates guy is for. Okay. Could we have based this off of I instead, the actual I loop, the I counter of the loop? You could, but you got to be a little careful doing that. And in order to be clear, I just wanted to use a separate variable called number of candidates that's going to represent how many candidates we've entered into these these arrays. So that's basically the implementation of input candidate info, right? We got a for loop. We do a bunch of cin and cout statements in order to grab the information, and then we basically say, hey, do you have any more? If the answer is no, we jump out and we return the specific number of candidates that we entered. So that is, that is your input candidate info module. Now, if we go down to the next module, the second module, let's go ahead and collapse this one. Okay, so this was our first module. The second module, calculate candidate info. Okay, and if you remember, we need to pass in the vote count array, right? Because that's got all of the vote counts for the different candidates. We want to pass in the vote percentage array. And this is more, the reason we're passing this in isn't so much for input, it's more for the output. Okay, so you'll see that vote percentage array is really needed more for output. And then the third thing we need is the number of candidates. Okay, so how do each one of these map to the parameters and the return type? Well, the vote count array, I've just included basically a parameter here to pass in the vote count array. For the percentage array, I've included a parameter here for the percentage array. For the number of candidates, here it is, the third one. Here's your number of candidates. And finally, let me zoom out just a little bit. Okay. And then finally, for output, vote percentage array, we basically are going to be calculating all of these percentages and sticking them into AR vote percentage. We already have that as the first parameter, so we don't need to add another parameter for the output here. Okay, so that's why you'll see that there's not a fourth parameter for the output. We already have it. We already have it right here. Okay. So how do we implement this? Well, basically, we need to get the total vote count, right? Because if you look at the note, if you remember from part one, before we can calculate the percentage, we need to calculate the total vote count, right? We have this array of vote counts, but that doesn't tell us the total vote count. And in order to calculate the percentage, right, in order to calculate a percentage, you need to add together all of your vote counts. So we needed to create this new get total vote count module. Okay, so we actually implement this right below this one. Let's take a look at that real quick. Get total vote count module, and you'll see that that is right here. And for the get total vote count module, you'll see that for input we want the vote count array, and for and also the number of candidates in that vote count array. And then for output, we're actually going to give the total vote count. So again, how do these things map to the function signature? Well, the vote count array is the first parameter. The number of elements stored in the array, that's the second parameter. And then finally, the output, or the total vote count, where I'm using the return type. Okay, the return type to pass back this total vote count. Okay, the actual implementation of get total vote count does nothing more than create a temporary variable called total vote count that's set to 0, and then we just basically loop through the number of candidates. We grab all of the vote counts out of the array, and we store it in an accumulator called total vote count. Once this loop is done, looping through all of the candidates, then we basically return the total vote count that we just calculate it. So the whole point of this method is nothing more than just adding together all of the vote counts that are inside of the array. Okay, so now that we know what get total vote count does, let's go back up to the one above it. And we'll see that we can use this new get total vote count with the appropriate information here. Right, get total vote count with the appropriate information in order to obtain that grand total vote count so that we can start to calculate the percentages, right? Because that's what we want this function to do. Calculate candidate info. We really want it to calculate the total vote count and the vote percentages. Okay, so this guy calculated the total vote count for us. Now this guy should calculate the percentages. Okay, so we set up a loop to go from 0 to all of the max number of candidates that are inside of, not the maximum number, the number of candidates that are inside of the array. And we basically say, hey, take the vote count that was assigned to that candidate and divide it by the total vote count, right? That's going to get our percentage. Now you need to be careful here, because if your array, your vote count array, if this is an array of integers, right, and it probably should be, because you can't really do a half of a vote. Okay, you can only do whole votes. The problem is if you leave this as an integer and you don't cast it to a double here, you're going to see that you're always going to have a 0 as your percentage, right? Because it's going to basically see an integer divided by a double, and it may cast it to, it should cast it to a double, but I know that earlier I was having problems with the percentage displaying until I added this double. So just be careful. Long story short is, anytime you have a division, make sure that you have a double divided by another double in order to avoid any kind of weird rounding errors due to incorrect casting. Okay, so we've got the vote count divided by the total vote count. We place those results inside of our new AR vote percentage array. That's going to actually store off all of those different voting percentages. Okay, so and that basically does what this module is supposed to do. We got the total vote count. We got all we calculated all of the vote percentage values, and now calculate candidate info is done. It's done its job, and we have all of the output in the arrays, and so calculate candidate info is done. All right, we went ahead and we actually talked about get total vote count already. Okay, so now we've got the last two modules here. Determine winner, right? And we can see that determine winner, for input we have a vote count array, we have a last name array, and we have the number of elements stored in the array. For output, we want to output the actual last name, the one last name of the winner, right? We don't want to output the entire array of last names because you won't know who won. The whole point of this determine winner module is to determine the last name of the winner, right? Process all vote counts and find the highest one with the last name. Okay, that's really what determine winner wants to do here. So how does that translate to parameters? This input here is this parameter here. Okay, this input here, last name array, is this input. It's this parameter here, and the number of elements stored in the array, this guy here, translates to this third parameter here. Okay, so the question is now, well, what about the output? Where are you using the determining the output? And the answer is here, this string return type. Okay, this string return type is the last name of the winner. Since anytime you have one output, if you only need one output to be returned, you can always just use the return type. Okay, and it's usually better to use the return type than pass by reference. Pass by reference is always a little scary because now all of a sudden you're kind of giving away the power to another function of controlling your variables, right? So return types are always better. That's why, excuse me, you'll see me anytime I have a single output, I usually map it directly to the return type. Okay, so that's how all of these inputs and outputs map to the different parts of the function signature. All right, so now if we open it up, we are going to see that the whole process, the whole point of this function is to process all vote counts and find the highest vote count, right, with the associated last name. Okay, that's what we want to do with this this function. And so what I basically did was create a local string variable here that's going to store the last name of whoever wins this thing. Okay, is there another way to do this? Sure, but I'm trying to be very clear in my code here. Okay, so you will see me create quite a few temporary variables when in real life. Maybe it'd be a little more efficient not to use so many temporary variables. But again, I like to be clear in my code, especially with these tutorial videos. All right, so once we have this string to store the last name, we need okay, this anytime you do a search for, let's say, the minimum or the maximum, you need to have a temporary variable that's going to store, if you're looking for the maximum, the highest, let's say the highest vote count found, right? You need a temporary variable that's going to store whatever that highest number is that you found up to that point. If you're looking for the minimum, right, you're going to basically have a variable that's going to store the minimum number found at that point. So anytime you have kind of this linear search algorithm, which is what we're doing here, okay, this determine winner is basically using a linear search to find the highest vote count. Okay, so we always need to create a temporary variable like this that's going to store either the highest value or the lowest value depending on what you're looking for. Okay, so we always need to declare a temporary variable that's going to store that information. Now we create the loop, and I call it the find max loop because that's exactly what we're doing, is we're trying to find the maximum value, and this is basically a linear search. Okay, so this is not an optimal searching algorithm. If we have 1 million entries, it's going to take a long time. There are more efficient searching algorithms than a linear search, but that's a whole another tutorial altogether. This is probably the simplest search algorithm out there, but it's also the most inefficient. Okay, and you're gonna see why. We basically start at the first element 0, and we go basically to however many candidates we have in the arrays. We loop over all of them. Okay, we loop over all of them, and we basically look to see, is the vote count at that particular location in the array the highest vote count we've seen yet. Okay, and so anytime we see a number, and notice that highest vote count found starts at 0, so anything is going to be higher than 0. So the very first value that it encounters, it's automatically going to be the highest vote count found. The first candidate in the array is automatically going to be the candidate winner. Okay, so basically the first element of the array is going to be initialized as the highest vote count found, and the first candidate in the array is going to be the candidate winner until, right, we loop back around. We go to the second candidate. Now, if the second candidate's vote count is higher than the one we just found previously, then guess what? We're going to overwrite that highest vote count found to, let's say, the second candidate's, right? We're going to overwrite the candidate winner to whoever the second candidate winner's last name is. Okay, and this keeps going, right? If the vote count, if the next candidate's vote count is not higher than the one we've seen up to that point, we're not going to change any of this information. That's why this linear, this linear search works, is because we're only storing off this information if it is the highest one that we found up to that point. Okay, so keep that in mind. Really try to envision in your brain how this searching algorithm is really working. Okay, and how the highest vote count found, this guy may change several times throughout this loop. But the good news is, by the time you reach the last element of the loop, this guy is going to be right because you've looked at every element in the array. Okay, so if you can try to really get to know this algorithm, this is going to help you out. You know, anytime you need to find a maximum or a minimum value, if you want to do it in the, this is one way to do it. It's not the most efficient way, but it's definitely one of the easiest ways to find a maximum or a minimum value. Okay, and then finally, once we're done, once we know the highest vote count found, okay, we basically also we know the candidate winner's last name, because anytime we found the highest vote count, we also stored off the candidate winner's last name. So all we have to do now is, hey, return that particular candidate winner. Remember, we're returning a string that represents the last name of the winner, and that's what this guy does. Okay, so that is your implementation of the determine winner. Now, for the display candidate info, when we're finally all said and done, and we want to display all this information. Okay, first of all, we need to look at all of our input, right? See how does that map to the parameters of the function signature. And you're going to see that these first three inputs basically map directly to these first three parameters. In fact, the first four inputs, right? The first four inputs map directly to these first four parameters. Okay, so the question then is, well, where's the output? Well, there is no output. The whole point of this module is to do nothing more than display the candidate information in rows and columns to the user. So we basically are just going to push out all this information using the cout statement, and we don't really have any output. Okay, so what's the process involved here? You're going to notice I added a cout fixed show point set precision, and this is basically because I'm trying to, if we remember the requirements, I want to create a nice pretty looking table like this, right? And in order to do this, we need to do a set precision for these values. We need to do a set width so that each column is a very particular width. So really this cout statement here is nothing, it's for the formatting of the rows and columns. Now, how can we output all of this information? Very simply, you create a for loop from 0 to however many candidates you have, and it's nothing more than one cout statement accessing each piece of the array using that variable, the I variable within the for loop. Okay, let's see if I can maybe zoom out a little bit more here, just to kind of help you guys out. Okay, so this is kind of the whole point of display candidate info, is to be passed in all of this information and then directly output it to the screen. All right, so once we have all this, now we have all of our modules defined. And in theory, if we were doing test-driven development, at this point, we would unit test all of these modules. Before we ever tried to put them together and use them together in main, we would unit test each one of these modules. And at the end of this video, I'll talk a little bit more about the actual testability of each one of these methods. You're going to see that some of these methods are very testable, others are not, and I'm going to explain why. But for now, let's go back up to main. Let's go back up to main and explain how does main put all of these modules, how do we have main work with these modules work together. All right, so if we look in main, we see that we need to create these new arrays, right? And these arrays are going to store our information. What I like to do is I don't like to use magic numbers. You should never use magic numbers. If we just stick in the number 5 here, nobody really has any idea why 5 is there. If we give 5 a nice descriptive name, like max number of candidates, now you understand, oh, well, maybe this election can only have 5 candidates, and you should always use that constant name instead of what we call those magic numbers. Okay, so I basically created those three arrays here, right, to store off those three important pieces of information that we see here in the requirements, right? This column, and this column. All right, and last name is going to be an array of strings. Vote count is going to be an array of ints, right? You can't have a half a vote, so that's why that's not a double. And the AR vote percentage is a fractional value, so that's why we declare that array as doubles. Now, in order to call the input candidate info module, look how easy this is. Because we did all of the work basically inside of input candidate info, the only thing we have to do is pass in the input and store the output, right? The output, this guy, that's what the return type does. That's what the return value does. It basically calls this function. Whatever this guy returns, it replaces this entire statement with the value that it returns, and we can store off that value just by using the assignment operator. We can say, hey, whatever this guy returns, I want you to take it and store it inside of number of candidates. And now we can always use this value later. That's why I always add this to the pseudocode. Store off output if return type is used, because a lot of people, a lot of new programmers will basically do this where they just call the function and they forget to store off the return type. Well, now that's kind of pointless, because the whole point of that function was to get you the information that was in that return type. So please remember, always remember to store off the return type, the value of the return type once it's called, just by doing something as simple as this. Okay, so now we know the number of candidates that we have. Okay, we've taken input candidate info. This function's put all of the candidates' last name into this array. It's put all of the vote counts into this array, and it said, hey, this many candidates was stored off into these arrays. All right, and now what we can do is call calculate candidate info, and notice that again, we did our homework. We did the modules right, to where all we have to do is call the module, provide the correct input, right? The output is the actual vote percentage array, so when this function's done, it will have updated this vote percentage array here with the new vote percentages for each one of the candidates. Okay, so by calling this method, we're basically updating this vote percentage array. How do we know that? Because of the pseudocode, right? We know that the output coming back is this vote percentage array. Next, we call the determine winner. Let's loop through all of the vote counts, right? Let's loop through all of the last names in the vote counts and determine who the winner is. And we see that as output, we have the last name of the winner, which is the return type. Okay, so we basically store off the last name of the winner by creating another temporary variable to store off that output called winner. Okay, so now this variable called winner actually stores off the last name of whoever won the election. And then finally we say, all right, now let's display all the candidate information. Okay, and we pass in all the parameters needed for this particular module. Okay, output is none. Why? Because we're pushing all of that information to the screen, right? We didn't need any output to come back for any of the other functions. And then finally, now that we have the winner, now that we've displayed all of the candidate information, we can actually display the winner of the election, right? And that was stored off up here under winner. We can just basically see it out right here. Okay, so that's the basic implementation. I mean, you can see that if we design our helper modules right, that the main module is going to be very simple. It's literally 1, 2, 3, 4, 5 lines of code. Okay, 5 lines of code, and it's very modular. If at any point in time we don't want to determine the winner, we can remove this line of code and it's not going to affect anybody else, right? If we don't want to display the candidate information, we can remove this line of code. It's not going to affect anybody else, right? Anytime you're designing your algorithm, you really want to modularize it and create these functions so that it's very easy. You can change it very easily, right? That's what companies are looking for, are programmers that write code where you can add features, remove features, and not break all the other functions that are out there. All right, so that's the basic solution. Don't forget to, at the top, you may need to include the string, right? Because we use strings. You may need to include IO manip for the set width and the set precision operators for the table. And then, of course, you always need the prototypes, right? If you define your helper modules below main, you always need to come up here and basically copy and paste those function signatures. Make sure your prototypes are up above. Okay, and then I just want to end on, going back to the unit testing. It's always, let's look at each one of these. For input candidate info, you're going to see that we have input that we can provide. We have output that the method provides. However, if you look inside input candidate info, you see a lot of CINs, a lot of COUTs. That immediately means that we would have to manually test this program without using, a mock framework to override these CIN and COUT functions. So this input candidate info would be pretty darn difficult as is right now to write a unit test for. So this one, not very testable because of the CIN and the COUT statements. You would have to manually test that. Calculate candidate info. Now this guy, yeah, we could very easily write a lot of unit tests, a lot of good unit tests for calculate candidate info because we have inputs, we have an output that we can examine to see if all the tests were performed correctly. So the unit testability of this function is very high. We should have no problems creating unit tests for calculate candidate info. For get total vote count, again, input's very specific, output's very specific. There's no CIN or COUT. We can unit test this, no problem. Determine winner, same thing. We can unit test this method very easily as well. No CIN, no COUTs. And then finally, the display candidate info, you're going to see there's a lot of COUT statements in there, so that would be a little difficult to unit test as well. So always try to keep your CIN and COUT statements isolated to a couple of functions so that all the rest of these methods can be unit tested. Okay, always try to do that. Okay, well, I think you guys should be pretty well prepared for the election result program now. Definitely let me know if you have any questions, and have a lot of fun with this. Keep in mind, software takes time. You can't just throw together a program in 15 minutes. But as you get to know the logical constructs, you're going to see that programming is a lot of fun. It's very rewarding once you're done. So, anyways, thank you very much, and I look forward to our next video.